Hello, welcome to Integrated Science for grade 9. This class we are going to talk about chemical compounds. Yeah, we all know what chemical compounds are. If we don't know, we're going to know what chemical compounds are at the end of the lesson. Okay, so let's start off with the objectives for this lesson. We're going to be able to define and explain chemical compounds. So these are the stuff we are going to know at the end of the lesson. Know some properties of chemical compounds. We are going to understand the concept of chemical formula, what chemical formulas are. We are also going to know how to name chemical compounds. We'll be able to write simple equations for chemical compounds or chemical reactions between the compounds, and we'll be able to balance those equations. So let's start off. In our homes or everyday lives, we come across chemical compounds such as these, like a basics or a common salt. Some of these compounds are toxic or poisonous. Some of the compounds are okay to use in our homes, like sugar. Sugar is another example of a chemical compound. Hydrogen peroxide. This one is used as a mouthwash. Water. We all drink water. Water is also a compound. Yeah. Vinegar. Vinegar is also a compound. All of these products are found in our homes. Alcohol is also a compound. This one is not good for you guys. Don't try it. Aspirin, it's a medicine. It's also a compound. Yes, so then what is a chemical compound? How do we define a chemical compound, or how do we explain chemical compound? A compound is a unique substance that forms when two or more elements combine chemically. So compounds form as a result of chemical reactions. So we are forming a reaction, or a reaction is taking place to form compound. The elements in compounds are held together by a chemical bond. So when elements combine to form the compound, what holds those elements together is what we are calling the chemical bond. So that bond is a force of attraction between the atoms or ions that share or transfer valence electrons. So in the chemical bond, we are saying that the chemical bond is actually a force of attraction. So what is attracting the atoms of the elements together to form the compound is what we are calling the chemical bond. Then we can define a compound or a chemical compound as a substance formed from the chemical combination of two or more elements that can normally be broken down into simpler substances by chemical means and have properties different from those of its component elements. Yes, that makes sense. So when a compound is formed, a unique substance is formed. That substance has different properties from its component elements. We are going to understand this. For instance, this compound here, we are seeing water. The green ball is represented by oxygen, and the two blue balls are represented by hydrogen. So we can see that water is formed from two hydrogens and then an oxygen. When we look at the properties of water and then we take the properties of oxygen and hydrogen, we can realize that the elements exhibit different properties from that of the compound formed, which is water. Another example is sodium chloride. Sodium is a metal, we all know that, and it reacts profusely with water. And then chlorine is also a poisonous substance. But these two elements come together or combine chemically to form a compound known as sodium chloride, which is a common salt, which is not poisonous, which is not even dangerous, which we use in our food. Another example is a hydrogen peroxide. So we see here that hydrogen peroxide is formed from two hydrogens and then two oxygens. Yes, It's also formed, it's a compound formed from hydrogen and oxygen, same as water, but in this case hydrogen peroxide is a whole unique substance different from water, H2O. So that is the differences, or that is the unique substance we are calling a compound. That brings us to the properties of compound. So what are some of the properties of compound? The constituents of a compound are present in a definite proportion. So if we are using two hydrogens and then an oxygen to form a compound, that compound will be different from using two hydrogens and then two oxygens to form another compound. Yes, so we are talking about definite proportion. The properties of a compound is different from the properties of its constituent elements. Yes, we talked about this from the previous slide. For example, another example is iron and sulfur. They are chemically combined. When these elements, iron and sulfur, are chemically combined, a new substance called iron sulfide is formed, and it has a way different properties from those of iron and sulfur. That makes sense. Also, the constituents of a compound cannot be separated by simple chemical means or process. Yes, if we want to separate the constituents of a compound, we need to go by a chemical means. Physical means, I'm sorry, won't work. Yes, and a compound is always homogeneous in nature. It's uniform. A compound is always uniform in nature. Also, formation of a compound is generally accompanied by evolution of energy in the form of heat or light. So when we are combining compounds, energy is evolved in that nature, and that energy is in the form of heat or light. Yes, so these are some examples of compounds and then their constituent elements. So water, hydrogen and oxygen, common salt, sodium and chlorine, magnesium oxide, magnesium and oxygen, hydrogen peroxide, hydrogen and oxygen, baking powder, sodium, hydrogen, carbon, oxygen, sugar, carbon, hydrogen, oxygen, alcohol, carbon, hydrogen, oxygen. So we see that sugar and alcohol are formed from the same elements, carbon, hydrogen, oxygen, but we should know that different proportions of these carbon, hydrogen, oxygen come together to form sugar, and then that's this different proportion for alcohol. Yes, so you can be asked to give the constituent elements for some compounds, so you can take this slide or this portion of slide a bit serious, and then you are good to go. Chemical formula. What's a chemical formula? Let's see what chemical formula is. What's a chemical formula? It's basically a symbol of a chemical compound using element symbol and subscripts to represent the ratio of atoms in the compound. So if we want to represent the compound, we use symbols of the elements in that compound and then subscripts to represent the ratio of atoms in the compound, or the amount of atoms in that particular compound. So we are going to represent some compounds with their chemical formulas. In a chemical formula, the elements in the compound are represented by their chemical symbols, and the ratio of the different elements is represented by subscripts, as we have noted earlier on. So consider a compound water as an example. Each water molecule we know contains two hydrogen atoms and then one oxygen atom. Therefore, the chemical formula of water is H2O. We are saying that we are representing the compound with the symbols of the elements and then the subscript of the ratio of the elements. So water H2O basically means that we have two hydrogen atoms and then one oxygen atom. Yes, as we are seeing in the picture, one big oxygen, one single oxygen, and then two hydrogen atoms. The subscript 2 after the hydrogen shows that there are two atoms of hydrogen in the molecule. The O for oxygen has no subscript. When there is just one atom of an element in the molecule, we give it a subscript. Yes, so there's another table for chemical formula for some compounds. So hydrogen peroxide, two hydrogen atoms, two oxygen atoms, giving us H2O2. Sodium chloride, one sodium ion, one chloride, or one chloride ion, giving us sodium chloride. Calcium iodide, one calcium ion, two iodide ions, giving us CaI2. Carbon dioxide is one carbon atom and then two oxygen atoms, giving us CO2. Why did we use ions here in sodium and then calcium? This is because in sodium chloride there is a complete transfer of electrons. We are transferring electron from the sodium to the chlorine. That is why we are using ions. So ions are formed before the compound is actually formed. So the sodium loses one electron to the chlorine, and then vice versa, the chlorine also gains an electron from sodium. Both of them become stable and then they form a compound, sodium chloride. Same happens in calcium iodide. For carbon dioxide and then hydrogen peroxide, there's a sharing of electrons between the atoms here. So the atoms share electrons. There is no complete transfer. They share electrons to be stable. That is why we don't use ions here. You further go into this at the senior high level, studying chemical bonding and the rest. Yeah. So you try out these examples. Write the chemical formula for these compounds. Pause the video, write the formulas for these compounds, and then you continue the video to see how good you did. Magnesium oxide, ammonia, calcium chloride, and then sodium hydroxide. Also copper sulfate, sorry. Yeah, so you can pause the video and then try your hands on these questions and see how good you did. Okay, let's see. Magnesium oxide, MgO, you had it right, I guess. Ammonia, NH3, calcium chloride, CaCl2, sodium hydroxide, NaOH, copper sulfate, CuSO4. Yes, so MgO, NH3, CaCl2, and NaOH. Yeah, so these are the chemical formulas for the compounds we are seeing there. For MgO, also you can use the valencies for naming or for writing the formulas for these compounds. For instance, MgO has Mg has a valency of 2 and then O also has a valency of 2, so these interchange and then they cancel out, so that's why we have an MgO. So you can use this to write the formula by interchanging the valencies, same as calcium chloride. Calcium 2, chlorine 1, they interchange, so calcium takes 1 and then chlorine takes 2, so we see calcium chloride. Or you can use the previous convention of naming or writing the formula, CaCl2, 1 calcium and then 2 chloride, 1 calcium ion and then 2 chlorides ion come together to form calcium chloride. the complete transfer of electrons from calcium to chlorine. That makes sense. Yes. So we are seeing the calcium chloride. Sodium hydroxide is NaOH. Hydroxide exists in that form OH. And then copper sulfate, also the sulfate SO4, exists in that form. So copper, we need one copper and then one sulfate for the compound copper sulfate. Copper sulfate. So you write the formulas as we are seeing there. I hope you had everything right. Okay, so move on to naming of chemical compounds. We've been able to write the compounds or the formulas for compounds, and we are given the compound. How about if we are given the formulas and we are asked to write the name for that compound? How are you going to go about that? Okay, let's see how you're going to do that. So let's look at these basic naming conventions. The name of the compound is built from the element and the construction of the compound. The name of the compound is built from the elements and the construction of the compound. So we are writing the name of the compound from the elements we are seeing in the formula, and then how the compound is constructed. Also, the name of the compound with two elements has two words, binary compounds. So binary two compounds. So the elements in that compound, we use a name for those elements to generate the name of the compound. Also, to get the first word, we use the name of the first element or the elements to the left of the formula. To get the second word, we use the name of the second element, then change the suffix to IDE, ide, at the end of the word. When there are two elements in a compound, which element goes first in the name? And so if the compound is made up of a metal element and a non-metal, then definitely the metal comes first. If the two elements are non-metal elements, then the first name of the element is the elements on the left side of the periodic table. So you consider the two elements, the non-metals, or the two elements, and then you choose which one comes first or which one comes on the left of the periodic table. You use that one first before the second one. The second one, make sure it takes the ID. So some of the examples of adding ID, we have oxygen as oxide, chlorine as chloride, bromine as bromide, and then fluorine as fluoride. So examples are NaCl, which is sodium chloride, the ID chloride. Sodium is a metal, so sodium comes first, chloride. Magnesium sulfide, magnesium is a metal, so it comes first. Potassium chloride, potassium is a metal, so it comes first, chloride. So what if there is more than one atom? So we are looking at atoms of the same element. So if an element has more than one atoms in the compound, how do we name that? In case where there is more than one atom, for example, two oxygen atoms in CO2, you add a prefix to the start of the elements based on the number of atoms. So here's a list of the prefixes we use. For one atom, we have mono, 2, we have di, 3, we have tri, 4, tetra, 5, penta, 6, hexa, and then 7, hepta. It goes on 8, octa, 9, nona, 10, deca, and the rest. Example, as we are seeing CO2, carbon dioxide, CO2, the 2, di, 2, oxide, carbon dioxide. So carbon comes first. Carbon and oxygen are non-metals. So which one comes first? Carbon is on the left side of the periodic table, so it comes before oxygen. So we have carbon, 2 oxygen, dioxide. N2O, dinitrogen monoxide. Nitrogen appears on the left side of the periodic table when we are considering nitrogen and oxygen. Dinitride. Okay, so two nitrogens. Calcium chloride. Carbon chloride. We have four chlorines, so carbon tetrachloride, carbon tetrachloride, carbon tetrachloride, four chlorines, and trisulfur dinitride. We have three sulfurs and then two nitrogens. The nitride comes last, and then trisulfur. Sulfur appears on the left side of the periodic table before nitrogen, so trisulfur dinitride. Use all of these rules when you are naming chemical compounds, when you are giving the formulas. Sulfur or trisulfur dinitride. Take note of that. Also, what if you are naming a polyatomic compound? These polyatomic compounds are those compounds with the SO4s or the PO4s or the SO3s or the NO3s. Yes, those compounds, they end with ATE. 8. They use different suffix, so most of them ends in ATE. 8 or 8. 8 is most often when the subscript is 4, and then 8 is most often and subscript is 3. So there are a few exceptions, which is the ides, hydroxide, and the peroxide, and the cyanide. So if you have a compound having hydroxide in it, it ends with hydroxide or peroxide or the cyanide. Yes, examples. So we are seeing here, examples are what we are seeing here. Sodium sulfate, sodium sulfate. So these are the common names when we are looking at the systematic or the IUPAC names. These will be named differently, but the common names is what we are considering here: sodium sulfate, sodium phosphate, and then sodium sulfite, because of the 3 SO3, sulfite. So when it's 4 it's 8, when it's 3 it's 8, sulfite. And the hydroxides, we have calcium hydroxide, and there's another hydroxide, potassium hydroxide. So these hydroxides are bases, yeah, basically bases. Calcium hydroxide and potassium hydroxide. Chemical equations. So we've got to know the formulas. So if we are asked to write a chemical equation, what's a chemical equation? Basically, a chemical equation is a shorthand way to sum up what occurs in a chemical reaction. So if we are chemically combining two or more compounds, we are forming a reaction. So the general form of the chemical reaction is what we are seeing there. Reactants giving us the products. So compounds come together to form, or compounds, we chemically combine them. Chemically combining them, those compounds are the reactants. Then what is formed? The new product formed is a product. Yes, the reactants in a chemical reaction are the substances that begin the reaction, and then the products are the substances that are produced in the reaction. That makes sense. The reactants are always written on the left hand side, as we are seeing here, reactants on the left hand side, and then the products goes on the right hand side. So the arrow pointing from left to right is indicating or telling us that the reactants change into products during the reaction. This happens when the chemical bonds break in the reactants and the new bonds form in the product. So when you are chemically combining two or more compounds, you break the bond in the reactants, and then new bonds form when the new product is forming. So that is what goes on in a chemical reaction. As a result, the products are different from the chemical substance than the reactants that started the reaction. Yes. So what is the general equation for the reaction in which iron rust? You remember when you studied rusting, you know that iron reacts with oxygen in the presence of water to form rust. That reaction, what general equation can you generate from that? Have you got that? Do you remember? I guess you do. Iron plus oxygen giving us iron oxide. So the iron and the oxygen are known as the reactants. Then a new product, iron oxide, which forms on the surface of the iron, that reddish brown substance known as rust, is what we are forming, or we are saying is a product. So we combine iron and oxygen to form iron oxide. Iron oxide. So can you give the products for the following reactions? Pause the video and then see if you can give the products for these reactions. Sodium plus chlorine, nitrogen plus hydrogen, calcium plus oxygen, zinc plus chlorine. Do that and let's see what you get. Did you get them right? Okay, sodium plus chlorine gives us sodium chloride, nitrogen plus hydrogen, ammonia, calcium plus oxygen gives us calcium oxide. Very good. Then zinc plus chlorine gives us what? Zinc chloride. Very good. Zinc chloride. Hope you had all right. Sodium, chlorine, nitrogen, hydrogen giving us ammonia, calcium oxygen giving us calcium oxide. Yes, very good. Okay, so we want to write the equations using the chemical symbols and then chemical formulas of the elements and compounds for the reactions from the previous slide. So instead of writing the word form of the equation, pause the video and then see if you can generate or use the formulas to write the equation. Sodium plus chlorine giving us sodium chloride. Do that and let's see what you get for all of the equations you are seeing. I hope you had them right. Na plus Cl2 giving us NaCl for the first equation. Second equation, N2 plus H2 giving us NH3. Third equation, Ca plus O2 giving us CaO. The fourth equation, Zn plus Cl2 giving us ZnCl2. The last equation, Fe plus O2 giving us Fe2O3. Okay, so how did we generate all of these? Take note that the molecules we are seeing, the Cl and H2O2Cl, those molecules exist in that form, H2. They exist as H2, N2. So you don't just write N plus H, write N2 plus H2. That is how they exist. So you write them as that in a chemical reaction. That is a representation of those gases. Yeah, they are gases. Nitrogen gas, hydrogen gas, N2H2, giving us NH3. Yes. So what if you are asked to balance these equations? How are you going to do that? Balancing of chemical equations. So let's see if we can balance these equations. Let's start with the first equation. Na plus Cl2. So Cl exists in the form of Cl2. That gives us NaCl. So sodium is reacting with chlorine to give us NaCl. The reactants, from the reactants, see the number of atoms of sodium we are seeing there is 1, and that of chlorine molecule S2. So we have 2 chlorines there. And looking at the products, we have 1 sodium and then 1 chlorine. So it's obvious that this equation is not balanced. So we need to do something to the equation to make the number of atoms in the reactants the same as that of the products. So what do? Let's add 1 NaCl to the first NaCl. Now we have 2 NaCls. Take note, you don't change the subscript. That is the form of the molecule. You don't change it. Okay, so try these examples. Fe plus O2. Yes, these are the equations from previous slides. So try and balance these equations. Pause the video, balance the equations. Let's see what you get. Did you get these answers? Yeah, I'm sure you did. Okay, so looking at the equations, you don't change the subscript. Take note of that. Zn plus CO2 giving us zinc chloride is already balanced. So we leave it as that. Yes, so you can visit this link and then you have more information on balancing of chemical equations. Yes, so what have we learned today? A compound is a substance formed from the chemical combination of two or more elements. Yes, we have got to know that. Also, we have learned that we can find compounds in our homes. Most of the compounds we use are compounds, or most of the products we use in our homes are compounds. Compounds are also used in medicine, agriculture, and then in the industries. Chemical formulas are a shorthand way of writing chemical compounds. Yes, we have learned that today. Also, chemical equations is a representation of chemical reactions using chemical formulas. On the left hand side of the equations are the reactants, and on the right are the products. Take note of that. Alright, so enjoy the rest of your day, and then see you, or let's meet on another video. Our next lesson will be measurements. We are going to review or solve more questions on measurements. Alright, thank you very much.